Hey guys, welcome back to the channel. Today we'll be solving LeetCode 36 valid Sudoku. So we're giving a 9 by 9 Sudoku board and we want to determine if it's valid. So for a Sudoku board to be valid, there are three rules, and if you ever played Sudoku before, you would know this. So in every row, there has to be only unique integers. In every column, there has to be only unique integers. And in every 3 by 3 box, there has to be unique integers. And if all three of these rules are met, we can return true, otherwise we're going to return false. So we can solve this in constant time with all three different types of solutions. We have the brute force, where we have three nested for loops. We can solve this in constant time with the hash set solution, which is the one I'm going to go over today. And we can also solve this in constant time with the bit mask solution. So technically the best solution is going to be the bit mask solution, but the performance gain from it is minuscule, and I think that it's just easier to understand the hash set solution. So that's the one I'm going to go over today. So let's get into the explanation. Okay, I'm not going to go through an entire iteration of this because that would take too long. I'm just going to give you the overall idea. So we're going to have a nested for loop that's going to loop through every row and column. So we're just going to go through all of these one by one. We're just going to go through all of these one by one like this. And at every single box or position square, whatever you want to call it, we're going to check, is it already in our rows dictionary set? And we're going to use a default dict with set as its default. And the reason we're going to do this is because we need to find out which square it's in, and we need to find out which row, column, and box it's in. So like every 3 by 3 box, we need to map it to something. We can't just have a normal set. We need to have a dictionary set or a hash set. So we're going to check, is it in this, is this specific box in the rows? And if it is, we're going to return false. And if it's in columns, its specific column in the set, then we're going to return false. And then we're going to check, is it in this box? So the box that we're currently in, if it's already in here. And the way we're going to know which box it maps to, so the rows and columns are pretty simple. To know what they map to, it's just a number, it's an integer. So this is 0, 1, 2, 3, 4, 5, 6, so on and so forth. This is 0, 1, 2, 3, 4, 5, 6. The way we know what box it's in, we're going to use some integer division tricks. So if you notice, let's say that it's at 2 currently. If we do 2 divided by 3, we get 0. Or yeah, we get 0. So it's going to be in this. It's going to know that we're in this box. And let's say if it was 3, for example. So the integer division 3 by 3 is just going to be 1. So it's going to know that it's in this box. And we can do the same with the columns. And we're just going to use this as a key. So we're going to use integer division of the row and column, and we're going to use a tuple, and this is going to be our key, and we're going to know which box it's in, and then we check, is it already in this box? If it is, we're just going to return false. And this problem is going to be much better understood when we get to our code. The time complexity of this is going to be constant because Sudoku boards don't increase in size, so we're just going to loop 9 times, or 9 times 9, 81 times, and space complexity is also constant. But if you want to think about it in a different way, you could just say that our space complexity and time complexity is n squared, if you want to think about it like that. And that's because each row, column, and box is going to store n squared values. So, and then we're going to have a nested for loop, but technically we can just replace the n with 9 to get 81 for each, and that's pretty much just constant. So let's get into our. We're going to start off by initializing our three dictionaries. So we're going to have a rows dictionary, and it's going to have its default dictionary as a set. We're going to have a columns dictionary. That's also going to be a set. And then we're going to have a boxes, and this is like the 3 by 3 boxes. There's 9 of those boxes. Then we're going to have 2 nested for loops, and we don't have to actually get the length of the board. We know it's going to be 9 because it's a Sudoku board. Same goes for the columns. And then we're going to grab the val at this specific part of the board, so the specific row and column. And if this val is a dot, we know that there's nothing there, so we don't have to check anything because it's empty, so we can just continue our loop. Then we're going to grab the index of the box. So these boxes, we're going to grab the index. And remember, I was telling you in the explanation, we're going to do that using a tuple where we use integer division like this. We're going to this is supposed to be column, and this is going to be our index. This is how we're going to index into the boxes dictionary and find out if we already have this val in that dictionary. So if the value is in rows r, the value is in the columns dictionary. So if the columns dictionary has this specific val at this column, or the columns dictionary has this specific value, this columns, then we're going to return false. Or we have this specific val in the box at this specific box already, where then we're going to return false. And after that, we can just add to our, we can add the specific val to the dictionaries. Just like that. And after we loop through this entire thing, if we don't end up returning false, we can just return true because that means it's a valid Sudoku board. Oh, looks like there's a little error. So it turns out I had a small bug. This was rows instead of columns. So now it should work. And as you can see, it worked and it's pretty efficient. This will run in constant time and constant space. Thanks for watching.